Welcome to this video on multi-jet fusion. Today we're talking about what multi-jet fusion is and how it works. Let's get started. So, what is multi-jet fusion? Multi-jet fusion is an additive manufacturing technology designed by HP, with its first printer being released in May 2016. MJF is part of the powder bed fusion family that also includes SLS and binder jetting. It produces detailed functional prototypes and end-use parts for low to mid-volume production. Multi-jet fusion printers produce plastic parts that are relatively strong, detailed, and have near mechanically isotropic properties. On top of that, MJF is fast, giving it an advantage over its close competitor SLS. Because MJF is fast, isotropic, and can print amounts from 100 to about 250 of small to mid-sized parts in one build volume in a day, it's a serious production solution for a wide range of manufacturing challenges. Let's talk about how multi-jet fusion works. An MJF printer consists roughly of a print bed, material recoater, and a thermal inkjet array. The process consists of two main steps. First, a layer of material is spread over the print bed by the material recoater. Second, the thermal inkjet array moves across the print bed. Fusing and detailing agents are applied onto the powder bed in areas corresponding to the part's geometry. The thermal inkjet array then heats the surface to fuse the material. This happens as the areas exposed to energy and reactions between the material and the agent cause the material to fuse together. It's interesting to take a quick look at the role of the detailing agent in this process. After the fusing agent is applied, a detailing agent is then applied at the edges of the fusing agent. It's crucial to understand that the detailing agent is a kind of black ink. By placing a detailing agent around the ink, it functions as a cooling agent when energy is applied. It prevents the part from bleeding into the powder. It's also why multi-jet fusion has its distinctive spotty grey look. HP furthermore states that the detailing agent helps to create smooth surfaces and fine detail. Moving on to materials, the jet fusion system largely focuses on PA12, which is most commonly used, PA11, and glass bead reinforced PA12. Right now, all materials for the machine are developed by HP and its partners. In addition to these PA materials, polypropylene, flexible TPU, and TPA are also available. In the future, metal and other promising additional materials will be available for MJF. Let's move on to the advantages of multi-jet fusion. Fast and cost efficient. MJF is a fast additive manufacturing technology. It can produce small to mid-sized parts within a day. With that said, it's important to know how to effectively fill your build chamber to maximize the speed of part production and costs. Part density plays a big role here. Let's take a look at an example. Understand that there is a limit to the amount of energy you can apply during the printing process. Meaning, if you go over a certain amount of part density, you might end up having too much part and too little energy. HP states that the magical density number is 8%. However, in practice, this number is between 8 and 12%. What does that mean exactly? Let's say you have a coaster that has a build room percentage of 0.07%. If the target is 12%, you can just divide 12 by 0.07 and you will see that you can fit 171 coasters into one build volume. A print like this would run around 8 to 11 hours. A great thing about multi-jet fusion printing is that the build chamber can be removed after a 3D print is completed and a new empty build tray reinserted afterwards. This way, the machine can start the printing process again and the other build can be taken elsewhere to cool. This is a luxury that SLS machines don't have, so higher uptimes on MJF machines. Design freedom. As MJF is part of the powder bed fusion family, it doesn't need support structures, as during printing, the powder provides the support. This allows for more design freedom and no visible removal marks. Multi-jet fusion is therefore suited for detailed geometries. Note that large flat areas must be avoided because MJF does not handle those well. If large flat areas can't be avoided, think about adding lattice structures. Mechanical properties. MJF parts are 97 to 98% isotropic, meaning they are mechanically consistent along all directions of the part's geometry. Multi-jet fusion is therefore great when you have crucial features on multiple surfaces and need uniform mechanical properties throughout the part. Minimum feature size. MJF can 3D print small features while still retaining detail. Its minimum feature size is 0.02 inches or 0.5 millimeters. MJF prints 80 microns per layer. Now, the disadvantages of MJF. The key disadvantage of multi-jet fusion is that it's a closed proprietary system controlled by HP. Although it should be said that some people see this as an advantage. It's a sort of easy-to-use plug-and-play system. HP also controls the materials for the solution and the software as well as the machines. The market for filament printers is a lot more mature, and it's therefore common to find open software ecosystems allowing users to configure the machine with different software and to use other material suppliers. This creates more freedom. MJF has limited material options. It's a relatively new technology. That means compared to other technologies, it doesn't have quite the array of materials to choose from. Although the post-processing for multi-jet fusion is relatively light, a part is never finished straight out of the printer. MJF is not optimized for printing bigger parts. However, deconstructing a design and printing different parts in different builds that are later assembled back together can be more economical than printing one bigger part many times over. This is especially true for MJF. Moving on to MJF versus SLS. Multi-jet fusion and SLS are in many ways similar technologies, but they have a few distinct differences that you need to carefully consider when choosing between the two. Part requirements such as material, speed, feature resolution, or mechanical properties will determine the best process for your application. Color and materials. MJF parts are almost always printed in a grey color due to the nature of the printing process. HP did have a full color printer, but this 3D printer has been discontinued. So there might be manufacturers that are producing HP parts in color, but HP doesn't sell these printers anymore. As a post-processing option, the grey MJF parts can be dyed mostly black. SLS, however, can print a broader range of materials, such as different nylon. SLS is usually printed white, but can be dyed in several different colors. Mechanical properties. As mentioned, multi-jet fusion parts are 97 to 98% isotropic, meaning they are mechanically consistent along all directions of the part's geometry. SLS is less isotropic. Part quantities. Multi-jet fusion is faster than SLS. This means it can 3D print larger quantities in a shorter amount of time. On top of that, the recovered powder from an MJF build is roughly 80% recyclable versus 30 to 50% from an SLS build. Part size. MJF is optimized for smaller and mid-sized production. However, MJF parts are good for being put together after printing if needed. Keep in mind that this is another step in your printing process. SLS, on the other hand, can build larger parts in one build. Post-processing. Multi-jet fusion requires printed parts to undergo post-processing after they're finished. When a print job finishes, the build unit is filled with a three-dimensional bed of unfused powder and the parts sit within. The first step in multi-jet fusion post-processing is cooling. This can take place within the build unit, or HP also offers a system which provides modular units which can be placed on a rack to naturally cool, allowing the build unit to go back into use for a new print without additional wait time. Once the build chamber is sufficiently cooled, an operator vacuums the unfused powder into a container for recovery. The 3D printed parts must then be bead blasted, air blasted, or water blasted to remove any remaining powder. This can be done manually or automatically using a tumbler, an ultrasonic cleaner, vibratory finishing machine. After powder material is removed, additional post-processing may be required for the parts. In addition, other finishing processes are possible, such as painting, coating, tumbling, vibro polishing, shot peening, bead blasting, and vapor smoothing. With that, we've come to the end of the video on multi-jet fusion. I hope you liked the content and learned something new. If you did, please drop a like down below and subscribe to the channel for future content. Thanks guys, take care.